Electrical noise. Electromagnetic radiation from nearby electrical devices can interfere with ultrasound signals. Improper grounding can create electrical loops that allow noise to enter the system. Wireless devices, such as cell phones and Wi-Fi networks, can emit radio frequency signals that can interfere with ultrasound. Certain high-power medical devices, such as MRI machines, can generate significant electrical noise. Here are troubleshooting steps to resolving the interference. Firstly, inspect the power cords. Ensure that the power cords are properly shielded and grounded. Replace any worn or damaged cords. Secondly, check the grounding. Verify that the ultrasound machine is properly grounded to the electrical system. Use a ground loop tester to ensure that there is a low impedance connection to ground. Thirdly, identify sources of electrical noise. Inspect the surrounding area for potential sources of electrical noise, such as nearby machinery, power lines, or fluorescent lights. Fourthly, test with different frequencies. Interference can vary depending on the frequency of the ultrasound signal. Try using different frequencies to see if the interference is minimized at the specific frequency. Fifthly, use radio frequency shielding. Consider using radio frequency shielding drapes or enclosures around the ultrasound machine to block out unwanted radio frequency signals. Sixthly, consult an electrical engineer. If you are unable to resolve the interference, consider consulting with an electrical engineer who can assess the electrical system and recommend solutions. There are specific considerations for hospital environment. Operating rooms are particularly prone to electrical interference due to the presence of high-power medical equipment. Ensure that the ultrasound machine is shielded from these sources. Restrict the use of wireless devices in areas where ultrasound exams are being performed to minimize radio frequency interference. Modern hospitals often use modular construction, which can introduce electrical noise due to poor grounding and shielding. Consider using shielded power cables and grounding straps between modules. Let's delve deeper into each of these points, providing more technical detail and actionable steps. Focusing on electrical noise, it is important to understand that medical equipment, especially older models, can emit significant electromagnetic interference or EMI. This EMI can couple into the ultrasound machine's sensitive electronics, causing artifacts and distortions on the screen. The power supply of the ultrasound machine itself can also be a source of noise, particularly if it is not properly filtered or shielded. The electromagnetic radiation emitted by nearby devices can be mitigated by increasing the distance between the ultrasound machine and potential noise sources. Metal enclosures or radio frequency shielding materials can be used to block electromagnetic waves and prevent them from reaching the ultrasound machine. Grounding issues are a common cause of electrical noise problems. A proper ground provides a low impedance path for unwanted currents to flow, preventing them from interfering with the ultrasound signal. Ground loops occur when there are multiple ground paths, creating a loop that can pick up electromagnetic interference. To test for ground loops, use a ground loop tester, which measures the impedance between different ground points. A lower impedance reading indicates a good ground connection, while a high impedance reading suggests a ground loop. To resolve ground loops, ensure that all equipment is grounded to a single, common ground point. Consider using isolated ground receptacles, which provide a dedicated ground path for sensitive equipment. Radio frequency interference is becoming an increasing problem in hospitals due to the proliferation of wireless devices. Cell phones, Wi-Fi routers, and other wireless devices emit radio frequency signals that can interfere with ultrasound equipment. The frequency range of ultrasound machines typically falls within the same range as many wireless devices, making them susceptible to interference. To minimize radio frequency interference, restrict the use of wireless devices in areas where ultrasound exams are being performed. Consider using radio frequency shielding materials to block radio frequency signals. Another potential cause of interference is other medical equipment. High-power medical devices, such as MRI machines, electrosurgical units, and defibrillators, can generate significant electrical noise that can interfere with ultrasound equipment. These devices can emit both conducted and radiated noise, which can travel through power lines and the air. To minimize interference from other medical equipment, ensure that the ultrasound machine is located away from potential noise sources. Use power line filters to block conducted noise from entering the ultrasound machine. Use radio frequency shielding materials to block radiated noise. Now let's look at the troubleshooting steps in more detail. When inspecting power cords, look for any signs of damage, such as frayed wires, cracked insulation, or loose connections. Damaged power cords can be a source of electrical noise and can also pose a safety hazard. Ensure that the power cords are properly shielded, which means that they have a layer of conductive material that blocks electromagnetic interference. Replace any worn or damaged cords with new shielded power cords. When checking grounding, verify that the ultrasound machine is properly grounded to the electrical system. The ground wire should be securely connected to a grounded receptacle or a dedicated ground bus. Use a ground loop tester to ensure that there is a low impedance connection to ground. The impedance should be less than 0.5 ohms. If the impedance is higher than 0.5 ohms, there may be a ground loop or a problem with the grounding system. When identifying sources of electrical noise, systematically inspect the surrounding area for potential noise sources. Look for nearby machinery, power lines, fluorescent lights, and other electronic devices. Try turning off these devices one by one to see if the interference disappears. Use a spectrum analyzer to identify the frequency and amplitude of the noise. This information can help you pinpoint the source of the noise. When testing with different frequencies, ultrasound machines typically operate at a range of frequencies. The frequency of the ultrasound signal affects the image resolution and penetration depth. Try using different frequencies to see if the interference is minimized at a specific frequency. Higher frequencies provide better resolution but less penetration, while lower frequencies provide better penetration but less resolution. When using radio frequency shielding drapes or enclosures can block out unwanted radio frequency signals. These materials are typically made of conductive materials such as copper or aluminum. The effectiveness of the shielding depends on the frequency and amplitude of the radio frequency signals. Ensure that the shielding is properly grounded to prevent it from becoming a source of noise. When consulting an electrical engineer can assess the electrical system and recommend solutions to resolve the interference. The engineer can perform a site survey to identify potential noise sources and grounding problems. The engineer can also recommend appropriate filters, shielding, and grounding techniques to minimize interference. Furthermore, for hospital environments, operating rooms require special attention due to the high concentration of medical equipment. Ensure that the ultrasound machine is shielded from these sources of noise. This may involve using radio frequency shielding materials, power line filters, and isolated ground receptacles. Coordinate with the hospital's facilities department to ensure that the electrical system is properly grounded and shielded. In areas where ultrasound exams are being performed, restrict the use of wireless devices. This includes cell phones, Wi-Fi routers, and other wireless devices. Post signs to remind staff and patients to turn off their wireless devices. Consider using a wireless signal jabber to block wireless signals in the area. Modern hospitals often use modular construction, which can introduce electrical noise due to poor grounding and shielding. Modular construction involves assembling prefabricated modules on site, which can create gaps and discontinuities in the electrical system. Consider using shielded power cables and grounding straps between modules to minimize electrical noise. Inspect the connections between modules to ensure that they are properly grounded. To summarize, troubleshooting ultrasound interference requires a systematic approach. Firstly, identify potential sources of noise. Secondly, check the grounding system. Thirdly, use shielding and filtering techniques. Fourthly, consult with an electrical engineer if necessary. By following these steps, you can minimize interference and ensure that the ultrasound machine provides accurate and reliable images. Remember that regular maintenance and inspection of the electrical system can help prevent interference problems. This includes checking the grounding connections, inspecting power cords, and testing for ground loops. A proactive approach to electrical maintenance can save time and money in the long run. Now let's look at some additional factors that can contribute to ultrasound interference. One factor is the age of the ultrasound machine. Older machines are more susceptible to interference than newer machines due to their less sophisticated electronics. Consider upgrading to a newer machine if you are experiencing persistent interference problems. Another factor is the type of ultrasound transducer being used. Different transducers have different sensitivities to interference. Try using a different transducer to see if the interference disappears. The location of the ultrasound machine within the room can also affect the amount of interference. Try moving the machine to a different location to see if the interference is reduced. The orientation of the ultrasound machine can also affect the amount of interference. Try rotating the machine to see if the interference is reduced. The humidity and temperature of the room can also affect the amount of interference. High humidity and temperature can increase the amount of electrical noise. Ensure that the room is properly ventilated and air-conditioned. The presence of static electricity can also cause interference. Static electricity can build up on surfaces such as carpets and clothing and discharge into the ultrasound machine. Use an anti-static spray to reduce static electricity. The type of flooring in the room can also affect the amount of interference. Conductive flooring, such as metal or concrete, can increase the amount of electrical noise. Use non-conductive flooring, such as carpet or tile. The type of paint on the walls can also affect the amount of interference. Conductive paint can increase the amount of electrical noise. Use non-conductive paint. The presence of metal objects in the room can also affect the amount of interference. Metal objects can act as antennas, picking up electromagnetic interference. Remove any unnecessary metal objects from the room. The use of extension cords can also contribute to interference. Extension cords can create voltage drops and introduce electrical noise. Avoid using extension cords if possible. If you must use an extension cord, use a heavy-duty, shielded extension cord. The use of power strips can also contribute to interference. Power strips can create voltage drops and introduce electrical noise. Avoid using power strips if possible. If you must use a power strip, use a surge-protected power strip. The quality of the power supplied to the ultrasound machine can also affect the amount of interference. Fluctuations in the power supply can cause electrical noise. Use a power conditioner to stabilize the power supply. The presence of harmonics in the power supply can also cause interference. Harmonics are multiples of the fundamental frequency of the power supply. Use a harmonic filter to remove harmonics from the power supply. The presence of transient voltages in the power supply can also cause interference. Transient voltages are short-duration voltage spikes. Use a transient voltage suppressor to protect the ultrasound machine from transient voltages. The use of uninterruptible power supplies, UPS, can protect the ultrasound machine from power outages and voltage fluctuations. A UPS provides a backup power source in case of a power outage. The regular calibration of the ultrasound machine is essential for ensuring accurate and reliable images. Calibration involves adjusting the machine's settings to compensate for variations in the transducer and electronics. Follow the manufacturer's instructions for calibrating the ultrasound machine. The regular cleaning of the ultrasound machine is essential for preventing the buildup of dust and dirt, which can interfere with the machine's operation. Use a soft, dry cloth to clean the machine. Avoid using harsh chemicals or solvents. The regular inspection of the ultrasound machine's cables and connectors is essential for identifying any signs of damage or wear. Replace any damaged or worn cables and connectors. The regular maintenance of the ultrasound machine's cooling system is essential for preventing overheating, which can damage the machine's electronics. Clean the cooling vents and fans regularly. Ensure that the cooling system is functioning properly. The proper storage of the ultrasound machine when not in use can help prevent damage and extend its lifespan. Store the machine in a clean, dry, and dust-free environment. Cover the machine with a dust cover. The proper training of ultrasound operators is essential for ensuring that they are able to operate the machine safely and effectively. Provide regular training to ultrasound operators on the proper use of the machine, troubleshooting techniques, and safety procedures. The establishment of a quality control program for ultrasound imaging can help ensure that images are of high quality and that the machine is functioning properly. The quality control program should include regular testing of the machine's performance, review of images, and documentation of any problems. By implementing these additional measures, you can further minimize ultrasound interference and ensure that the machine provides accurate and reliable images. Remember that a proactive approach to electrical maintenance and quality control is essential for preventing problems and extending the lifespan of the ultrasound machine.